DNA, when it copies itself, is pretty accurate because it doesn't want to make a mistake, right? It's very important. You know, you have your color eyes, your color hair, you know, because of your parents. They each contributed part of your genome, all right? But what you find is that sometimes mistakes are made. You will have a mutation, okay? Like malaria, for example, okay? The disease malaria, it's mosquito-borne. Particular individuals have a given mutation, and they have sickle cell, red blood cells. That actually confers a selective advantage in that the malaria parasite can't actually replicate in those cells. So in that particular location, those people are actually protected. So you have something, sickle cell anemia, that's not a good deal, but then there's a selective advantage because you're not actually so prone to, you know, the whole malaria disease process. And I think that God knows that mutations are part of what needs to happen. But I think he's a God of processes. And you see this in how DNA replicates, you see this is how proteins are made, and when you have a mutation, sometimes, you know, you have bad deleterious effects. Cystic fibrosis, for example. You have a mutation there, you have a bad protein made, you have an awful lung disease. I mean, there's nothing good about that. There's no selective advantage. Is there an advantage of something that we would look and say, gee, that was really positive? Well, if you look at how certain animals have adapted to, like, you know, climate change, or, you know, the true Darwinian sort of evolution, you know, like, well, they had a harder beak so they could crack open the shells or something like that. I mean, I think, you know, adaptation because you had a particular mutation, I mean, I think that that's real. Is that enough to explain, you know, the distinct speciation? Like, this is how a finch, you know, went to an elephant. I mean, I'm taking liberties with that. I would say no. But we see these modifications, even like in a little dog. Like, you see a dog and they have certain tendencies in terms of a coat or a color or something. I mean, maybe an advantage in terms of like breeding or something like that. That would be like an advantage. I think most of the mutations that we focus on as scientists do have negative consequences. It's like, this is a genetic marker for breast cancer, for cystic fibrosis, so on and so forth. So off the top of my head, something that mutated and that was really good. I mean, I think a lot of times they will take this and they'll like develop a process like PCR or something like that. They can sort of incorporate those in there. Off the top of my head, I hope I'm not missing something, I can't really think of like, well, this was a mutation and it was definitely good.